Hi, everybody. Okay, so we're going to do a review of chapters 5, 6, which is conservation of energy. So let's take a look at what we've done so far. Okay, so first things first, what is energy? Yes, what is energy? I'm asking you. Okay, so the ability to do work. Okay, so without energy, of course, all of the stuff that we've talked about in chapter 1, where we talked about velocity, acceleration, we talked about forces, we talked about projectile motion, none of that is possible without energy, right? Now, we talked about the following formula, work, yeah? Who remembers the formula? Okay, so FD cos theta, and of course F stands for force, and this was displacement or distance. Okay, there was another formula that we also looked at. Work was change in energy. So any change in energy is described as being work. Any change in energy. Okay. All right, so this is what we started with when we first looked at this. Then we talked about positive work and negative work and zero work. And who can tell me what the differences for all three are? Yeah, what was positive work? Yes. Object work? Okay, so first things first, your velocity increases. That's how I know that the work is positive. Number one. And what else? Yeah, that's correct. Your force and your displacement are in the same direction. So force, displacement are in the same direction. Okay, so that was positive work. Negative work, what's criteria? Yeah. Okay, so first thing first. So your force and your displacement are in opposite direction. Okay, so if they're in opposite direction, that's usually a sign that it's negative work. What's another criteria for negative work? Another sign, object slowing down. So normally, if an object is slowing down, what's the force that we're looking at here? Friction. That's correct. Okay, and the last one that we did was zero work. What was zero work? Yeah? So your force and your displacement are perpendicular to each other. Okay? If they're perpendicular to each other, of course, then there is no work that is being done, because the displacement is in no way, shape, or form in the direction of the force. So if I was holding up a tray, for example, but I'm moving horizontally, then that would be something that's considered perpendicular. That's zero work. However, if I'm lifting up something or lifting it, bringing it down, that would be work, because that's in the direction of the force. Okay, are we okay with this? So far so good. So this was positive, negative, and zero work. Okay, what's the next thing that we did after this? Yeah, what's the next topic that we studied after this? Yes. So energy. Okay. Okay, so we talked about the conservation of energy. Okay. And basically, conservation of energy states that, okay, so energy cannot be created or destroyed. Okay, it just gets transformed from one form to another. So there's transformation. Okay. And then we talked about how the total energy of a system always stays the same. So E total before equals to E total after. Okay, and of course this E total can be made up of any and all numbers of energy. So for example, if I have an object that is on the top of a building and it's just sitting there, the total energy at the top would be made up of what? That will be gravitational potential energy at the top. As that object starts falling down, my total energy is changing between Eg and Ek, and as the object falls onto the ground, that total energy converts to Ek. That's an example of total energy. So we're going to be using this to solve for any questions that deal with velocity and height before and after. Okay, I think at the rate that we're going, I'm not sure we're going to be able to put heat on this video. We'll have to do another video just for heat. Okay, that will be chapter 6. So this is chapter 5 that we're doing right now. Okay, so here we can write down stuff like Eg plus Ek, which equals to Eg plus Ek after. Okay, so in this situation, if I have a ball that is falling from the top of a building, this would be Ek 0 at the top, and at the bottom, Eg would be 0 at the bottom. And then so you would have, okay, which would be our next slide. Okay. Of course, my formulas for gravitational potential energy. Okay. So my formulas for Eg, which equals to mgh. So gravitational potential energy. Okay. Now don't just say potential energy, because potential energy basically means it could be potential for anything. It could be elastic potential, it could be nuclear potential, it could be chemical potential, right? Potential is just a word, means there is potential for it. Okay. So we are talking about gravitational, so therefore this is known as gravitational potential energy. Kinetic energy, of course, is Ek equals to half mv squared. M is your mass, g is gravity, gravitational attraction, h is height in meters. Here, of course, is mass, okay, and v is your velocity. Of course, all of this is measured in joules. Joules and joules. Okay, kinetic energy. So kinetic energy, any time an object is moving in any way, shape, or form, that is kinetic energy. So even if particles are moving, which we call, what do we call when particles are moving? Vibrations, also known as the measure of the vibrations of particles, known as temperature. That's all we're doing. When we're measuring temperature, all we're doing is measuring how quickly are they vibrating. That's all we're measuring. We're measuring the vibration of particles. Okay? Are we okay with this? So far, so good? Okay, so this is gravitational potential energy, kinetic energy. Have we missed anything so far? We haven't missed anything. Sure? Yeah, we do. Okay, so I'm going to erase this. Okay, yes. Okay, so if you want to talk about that, can I erase it? So basically you're saying that if I have Eg before and Eg after, or Ek after, and I've got mgh, which equals to half mv squared, if it's the same object that we're talking about on both sides, of course my mass is going to be cancel out, right? So you could write this down as v equals to the square root of 2gh. Okay, but of course you got to do this individually for every question. You can't just generalize. Okay, all right. Yeah, the next thing that we're gonna do is take a look at, what do we say we're gonna take a look at? Power. Okay, so power. Of course, what is power? Power is, okay, so change in energy divided by time. Okay, or work divided by time. And of course, work is in joules, time is in seconds, which gives you what? Okay, power is how quickly are you doing work? How fast are you doing it? How quickly are you moving? So when we're talking about a car, that would be known as horsepower. Okay, so horsepower for engines, for example. which is literally how much power in terms of horses there is for your vehicle or for your lawnmower or so on and so forth. Okay, are we good with this? Power. The next thing that we did was efficiency. Now you've already got the formula for efficiency, but because this is the energy formula, it's E out divided by E in times 100%. Now this is for all energies. Okay, any energy, the amount of energy that you are actually using, so actual use of energy, okay, over the total energy use of energy, well, total energy in system. Okay, actual over the total. So this is efficiency. What's up? What's a question? You mean like do a question? Maybe later. Okay. Are you copying this down or right, Sherban? You're on the video now. Forever. Hey. Hi. Hey Darius, what's up? Say my name. Okay, all right. So we're gonna stop.